Here's a little homework help for Unit 3, Lesson 13. Today we've been working with solutions to linear equations. Remember, a solution to a linear equation is any ordered pair that makes an equation true. In this case, we are given the values of x and y. And we're supposed to be able to find the solutions for their corresponding ordered pair. And we need to use decimal notation if necessary. When we talk about these ordered pairs, so talk about number A, what we're doing with this one, to be able to find the value of y, we need to substitute the value of x. So that means for the first situation, y is equal to 6 times the value of x that was given right here, x equals -3 plus 8. 6 and -3 is -18, and -18 plus 8 means that y is equal to -10. The x-coordinate, if we want to find out what x is, then we have to use what we know about y, and y is 2, which means 6 times x plus 8 is equal to 2. In this case, I'll subtract 8 from both expressions, giving me -6 is equal to 6 times x. Dividing by 6 on both expressions tells me x is equal to -1. All right. Let's go ahead and look at D. D looks a lot more complicated. Let's do the same thing with these and understand that we're going to use, again, x and y. But remember that it also says that we can use decimal notation if necessary. On this one, I think I'm going to go ahead and use decimal notation. And I see that y is equal to 75 hundredths times -3 minus 2 and 5/10. Now, the cool thing about this is I have this little calculator that I can go ahead and use. And then I'm going to simply see this as 75 hundredths times -3 is equal to -2 and 25 hundredths. And then I will further subtract 2 and 5/10 to give me a solution of -4 and 75 hundredths. Now, the reverse side of that is, what if I want to find the value of x? When I find the value of x, that means that y would now be equal to 2, and 2 is equal to the 75 hundredths times not times -3, we don't know this one yet, times x, that's what we're trying to find, minus 2 and 5/10. So we go ahead and go through the process that we did before, where we add 2 and 5/10 to eliminate that from the expression. To keep equality, we have to use the addition property of equality and add to the expression here on the left, which now gives us 4 and 5/10 is equal to 75 hundredths of x. Divide that by 75 hundredths to get 1x. Divide the 4 and 5/10 by 75 hundredths. And we see that we have 4 and 5/10 divided by 75 hundredths equals 6. So we know that x must be equal to 6. And there we have a couple of problems where we have a couple of solutions. I hope that's a good start for you. Complete the rest of those on your own. In the next problem, we see that we have a true or false statement. We need to check to see if these 3 points lie on the same line. Let's see how much work we have to do. We need to address this as either true or false, because either all 3 points, no points, or 1 point is true. So if this is false, then it's because no points or 1 point lie on solution. But if all 3 of them are true, then we would say this is true. But I would venture to say if 2 of them are true, then the third one must also be true, because that one's not a solution that we have to worry about. So let's test them. We take the equation y equals 4/3 of x plus 5. And we want to go ahead and start substituting. Let's go ahead and check out 6 and 13. Now we have 13 for y. We have 4/3 of 6. Since I'm going fraction, I want to multiply by a fraction. 6 over 1 plus 5. And now we're still wondering, is 13 really equal to 24 thirds plus 5? Is 13 really equal to 8 plus 5? And it certainly is. So this one is true. So we know at least one of these solutions is true. That one's good. Let's go ahead and check another one. Let's do the 21 and 33. So we need to substitute 33 for y is equal to 4 thirds of 21. And then we add the 5. 33 is equal to 84 thirds plus 5. I don't know exactly what 84 thirds is, so I'm going to go ahead and check that real quick. 84 divided by 3 is equal to 28. Pretty helpful tool there. 33 is equal to 28 plus 5. And I know that to be a true statement, so this solution is also true. Make sure that this third one really is a true statement by using substitution before you decide if this is true or not, because if that one is false, then we know that the whole situation is false. Number 3, we have the linear equation y equals 1/4 of x plus 5/4. We need to know, is the solution 1 and 1 5/10 really a solution to the equation? Remember, it will make the equation true, so we're testing to see if 1 5/10 is equal to 1/4 of 1 plus 5/4. We also need to check to see, and I write this question mark because we're questioning if whether it's equal or not. We also need to see if 4 is equal to 1/4 of 12 plus 5/4. In order to make this a true statement, the two expressions have to be equal to each other. I do want to talk about the x-intercept in this situation. We didn't talk a lot about it in the lesson, but I wanted to help you out with this one. When we talk about the x-intercept, this is the one where I made that big table and I said x, y, and I had the equation right here. And I said, if I want to find the x-intercept, I need to be able to find the x-coordinate, right? So by finding that x-coordinate, what I would be doing with this is that would be my blank space, and I would actually substitute 0 for y. That means that the x-coordinate, remember that on an or coordinate plane, the x-axis has an equation of y equals 0 because any ordered pair on here, the y-coordinate is actually equal to 0. So when we talk about the x-intercept, we have to have the y-coordinate being 0, which means that we have 0 equals 1/4 of what? Plus 5/4. So we have to be able to make this equal to 0. Go ahead and do the solution piece of this. I would recommend one thing with this. Since we're dealing with fractions, that might be a little bit scary. You might want to multiply the entire equation to make it 4 times bigger. That might make it easier, or you can just simply take this and subtract the 5/4 on both sides and multiply them by a reciprocal of 4, and you'll be able to find that solution. Give it a shot. I know that that's telling you a lot to do. I want to see what you can do on your own. The next problem is going to be a review problem from lesson 211. What we need to recognize from this is that the coordinates, we need to find the coordinates of B, C, and D. So I need to find this one, and this one. Knowing that AB, the length of this segment right here, is 5 units, and the length of this segment right here is 10 units. I think the easiest thing would be to find B first. Knowing that this is 5 units across, that means that my x-coordinate, which is currently -2, is going to be increased by 5 units. If it's increased by 5 units, that means my x-coordinate of point B has to be equal to 3. So we're going to just slip a 3 in right there. If that's a 3, then we're moving up from that point from -5. We're moving up 10 units because that's the length of segment BC. That tells me that y has to be equal to 5. So that's that ordered pair. Now, how would this help me to find point D? Well, point B is at 3 and negative 5. Okay, whoops, I forgot my negative sign right there. I found for point C, my mistake. But we know that this has to be negative 5 right here because it's on the same horizontal plane as this y coordinate right there. The y coordinate didn't change. So in reality, I should have seen it like this, that this y coordinate is just simply translating over here to the exact same thing. I had 3 and I had negative 5. I come up to C. I know the x coordinate is still the exact same. It's 3. But I'm coming up 10 units, which makes that a positive 5. Now the question is, how do I find D? I'm going to give you a little hint here. This is the y-axis, and the entire length here is 5 units. Over here to here, that's to negative 2. That must be 2 units. Here to here, this ordered pair was 3 for my x. That means that this distance is 3. That will tell us right here a little bit of help with this as far as coming up with some information towards a dilation of the figure. This moves from 10 down to, or excuse me, the length right here goes from 5 to 2. We have to consider how to use that exact same scale factor to be able to find the length of that side right there. And that should theoretically help us to figure out the value of y. I'm going to let you ponder on that and work on that one a little bit on your own. I don't want to give away too much on it because I know you can do it. So give that one a shot. Final question of the homework is one more review problem from lesson 3-9. Match each graph of linear relationships to a situation that most reasonably reflects its context. So most reasonably reflects the context means that I'm going to look down here and I'm going to look at these situations and look at each of the graphs. Graph A, graph B, graph C, graph D. What I'm going to suggest with this, there's no numbers that are given. Okay, so we're going to look at a couple of things and recognize what's happening. For this graph, we're talking about y is the distance. So I'm working on this one. Y is the distance left to go. Left to go. That means that the distance left to go in a car ride after X hours of driving at a constant rate towards its destination. The distance left to go means that we are decreasing our distance as we go. That's a big helpful piece because that means now I can look at one of these that shows a decreasing slope. In fact, there's only one of them that's a decreasing slope. That tells me that this is graph D. So I can move this one right in here to graph D. Y is the temperature in degrees Celsius of a gas being warmed in a laboratory experiment. This word right here, warmed, will tell me what that is. Degrees in Celsius means that we have to consider the ratio that's going along there as we're working. Let this next one right here, Y is the amount of calories consumed eating X crackers. Well, think about how many calories you're going to get if you eat 0 crackers. We know this one right here is proportional, so I'm thinking about looking at 0, 0. And then how about this one? The weight of a kitten that is X days after birth. I know that can't be 0, 0, but I also know it can't weigh very much. It has to be a little bit, and that weight has to steadily increase. So consider these words and consider those pieces. Make sure you're matching things up appropriately to where we're at when we're talking about the number of, when we're talking about the crackers. There's only one situation that will work for that experiment. When we're talking about the kitten, obviously it can't be right here because kittens don't start with a negative birth weight. Think very, very thoughtfully about each of these situations, and I think it will make sense for you. Questions? Let me know. Thanks for stopping in.